Someone asked me once, why is the speed of light so fast? And I said, well, that's a funny kind of question because fast compared to what? And the person looked at me like I was being difficult, but I wasn't. I mean, that's actually the whole problem right there, wrapped up in one little question. Let me back up a second. When we say light travels at, what is it, about 186,000 miles per second, that sounds fast. It is fast. I mean, it goes around the Earth 7 times in 1 second. 7 times. I find that, when you really sit with that, it's kind of staggering. But the question that's always bugged me in a fun way is not how fast it goes. It's why that number? Why 186,000? Why not a million? Why not 10? And here's the thing. I don't think most people realize what they're actually asking when they ask that question. So let me try to come at it from a different direction. When I was younger, I used to play around with magnets, little bar magnets, the kind you get at school. And you'd push 2 of them together, same poles, and you'd feel this invisible thing pushing back. You couldn't see anything. No wires, no hands, no nothing. Just this force sort of floating there in the space between the magnets. And I remember thinking, well, how does that magnet over there know what this magnet over here is doing? How does the message get across? And it turns out that question, the magnet question, is almost exactly the same question as the light question, because the answer in both cases is the same fellow doing the work, the electromagnetic field. Now here's where it gets interesting. In the 1800s, this Scottish physicist named Maxwell, James Clerk Maxwell, he wrote down these equations, beautiful equations. And what they described was how electric fields and magnetic fields kind of reach out and grab each other and create each other and pass that creation along, like a long chain of people handing something down a line. And when he worked out how fast that chain passes the message along, he got a number, a specific number. And it came out of the equations almost by accident, this particular speed. And that speed matched the speed of light. Now wait, think about what that means. He wasn't calculating light at all. He was just fooling around with electric and magnetic fields, and out popped the speed of light. And he must have sat there and thought, well, that's something. That is really something. And that's what gets you, you see. The speed of light isn't fast because of some separate rule about light. It's fast because of the nature of electricity and magnetism. Those 2 things, the electric field and the magnetic field, they have a certain stiffness to them, a certain way they resist being disturbed and then spring back, like a rubber band sort of. And the speed that a ripple travels through that rubber band, that is the speed of light. So in a sense, you could almost say the speed of light is the speed of electromagnetism. That's all it is. But now I want to push this a little further because there's something even stranger hiding underneath. You see, when Einstein came along, he looked at Maxwell's equations and he asked a question nobody had thought to ask. He said, suppose you were riding alongside a beam of light. What would you see? Would the light look like it was standing still? And the answer, which comes out of the math if you follow it honestly, is no. You can never catch up to light. No matter how fast you go, light is always moving away from you at the same speed, 186,000 miles per second. Always, no matter what. And that is not intuitive at all. I tried to explain this once to my sister, and she said, that can't be right. If I'm going 99% the speed of light, and you shine a flashlight ahead of me, I should see the light creeping away from me at just 1% the speed of light. That's how speeds work. You subtract. And I told her, I know. That's what everybody thinks. But it doesn't work that way. And she said, why not? And I said, well, here's the honest answer. Because space and time bend to make it work out. Space actually squishes. Time actually slows down. And those 2 things bend just exactly the right amount so that the speed of light always comes out the same. Now, I can't explain to you why that is. Not really, not in a deep way. Nobody can. What Einstein did was he said, all right, let's just accept this as a rule. Let's say the speed of light is the same for everybody, always, and see what follows from that. And what follows from that turns out to be the whole of special relativity. Mass and energy being the same thing. Time slowing down at high speeds. Length getting shorter. All of it falls out of that one assumption. But why is that assumption true? Why does the universe work that way? I don't know. That's the honest answer. There's a sense in which the speed of light isn't just a speed. It's more like a conversion factor between space and time. You know how you can convert miles into kilometers? There's a number you multiply by. Well, the speed of light is like that, except it converts seconds into meters. It connects the space directions and the time direction of the universe, and 186,000 miles per second is just what that conversion factor happens to be, in units that made sense to people in the 1800s who were measuring things with rulers and clocks In the units physicists sometimes prefer, the speed of light is just one, not 186,000, just one. And when you write the equations that way, a lot of the mystery sort of dissolves. Not all of it, but a lot. Which is kind of curious, isn't it? That the mystery might partly be a mystery we made ourselves by picking funny units. But not all of it, no. There's still something genuinely deep here, because even in those natural units, light still moves, it still propagates, it still takes time to get from here to there. And the sun, which is 8 light minutes away, well, if it disappeared right now, we wouldn't know for 8 minutes. We'd just be sitting here happily for 8 minutes, not knowing the sun was gone. The information can't get here any faster, because there's a speed limit on information itself. And that's what I find astonishing. It's not just light, it's not just radio waves, it's information, it's causality. The universe has a speed limit on how fast one thing can affect another thing. 186,000 miles per second. That's the speed of cause and effect. Why that number? I'm going to be honest with you, we don't know. And I find that, strangely enough, more wonderful than any answer would be.